Assalamu alaikum and welcome back to Relativity Part 2. So we had left off talking about how we see the world with the example of you standing on a platform and a guy on a train throwing a ball, and how velocities add in the natural way that we understand. Behind this understanding that we consider perfectly natural, in fact intuitive, is the assumption made by Galileo, by Newton, by everyone before Einstein, that time and space are absolute, that they're independent and separate aspects of objective reality, and that they don't depend on the physical events that are taking place on that stage that is made up of space and time. So, if you and I have accurate timekeeping devices, 5 seconds is 5 seconds. It doesn't depend on my location or your location, how I'm moving, how you're moving. Time is absolute. And in Newton's own words, absolute, true, and mathematical time of itself and from its own nature flows equably without relation to anything external. So, the issue came when Galilean relativity was applied to light instead of to a ball thrown on a train. Some years before Einstein, the scientist James Clerk Maxwell had developed his equations of electromagnetism, and light, of course, is an electromagnetic wave, and found that the speed of light is a constant that really has nothing to do with people's motion. So, the speed of light becomes one of the laws of physics that should be the same in any reference frame. Now, people had assumed that because light is a wave, you can do interference experiments and pass light through two slits, and you get constructive interference and destructive interference and so on. Light behaves like a wave. All waves travel through a medium. And so the sound waves, for example, when I'm recording this presentation, are traveling through the air. So if there is no medium, if you were to yell to me in empty space, I couldn't hear you, because there is no air for the sound waves to travel across. Water waves, of course, travel through water. And it was assumed that light waves have to travel through a medium, and that this medium was some invisible substance filling the universe known as the ether. And that this ether forms an absolute frame of reference. If you are at rest with respect to the ether, then you are absolutely at rest. If you're moving with respect to the ether, then we can say that you are truly moving. This bothered Einstein. He said, no, that's not reasonable, because then the speed of light would vary depending on your state of motion, and that, of course, is what Galileo and Newton would have expected anyway. But Einstein believed that all of the laws of physics are exactly the same for someone at rest or somebody moving at a constant velocity for all inertial reference frames. That means if the speed of light is part of the laws of physics, as Maxwell had shown, that had to be the same also. This notion was impossible for people to understand. In fact, two very famous scientists named Michelson and Morley, who believed in the ether, tried to measure the differences of the speed of light as the Earth rotated around the Sun, figuring that as it goes in one direction it would be moving one way with respect to the ether, and as it goes in the other direction in its revolution it would be moving opposite that, and because light moves at its speed with respect to the ether, there would be detectable differences in the speed of light for different positions of the Earth. They did that experiment, they found none. That was very surprising. Let us talk about what that means in practical terms. Let's go back to our example of the train and the platform. The speed of light, by the way, is usually called in science c, and that's the speed of light, and that speed is about 300 million meters per second, extremely fast. And it's a very fascinating story how human beings discovered that light actually has a finite speed and doesn't travel infinitely fast. I would have never thought of that. Anyway, according to Newton and Galileo and to everyone before and since, if we have a train traveling with speed v 0.5 c, so the train is traveling to the right at half the speed of light, then somebody shines a light, and that light, of course, travels with the speed of light, speed c, then to me, the stationary observer here on the platform, I would measure this light to be traveling at 0.5 c plus c, just like with the baseball, 10 meters per second plus 15 meters per second, I would measure the speed to be 1.5 c. But according to Einstein, in his mind, in his belief, in his theory, that should be impossible. Everybody should measure the same speed of light. This guy measures it to be c, and I measure it to be c. So light would behave completely differently than, for example, a baseball. Conversely, if I'm in a rocket traveling at 0.8 c and I'm chasing a beam of light that you shined from the platform, then relative to me, it should have a speed of 0.2 c, just like the car traveling at 50 miles an hour and I'm behind it at 40 miles an hour. Relative to me, it's moving at 10 miles per hour. But according to Einstein, he said, no, that's not the way the universe should work. The way the universe should work is because the speed of light is a law of physics, everybody should measure it to be c. I measure it to be c when I shine it, and you're chasing it at 0.8 c, but you still measure it to be c. And this was entirely counterintuitive. It agreed completely with the experiments of Michelson and Morley, but in fact those experiments really didn't influence Einstein's thinking. There's even a debate as to whether he was aware that Michelson and Morley failed to find any differences in the speed of light in their carefully designed experiments when he published his first paper on relativity, or whether he was entirely unaware of it. If he was aware, it was only a minor influence. He had a deep-rooted belief that the symmetry and beauty of the universe dictated that the speed of light should be the same for all observers. Insisting on that led to an unbelievable revolution in how we see the universe. So that is what we will be talking about and discussing. And what I would like to do is give you a little mental break, and then inshallah, beginning in the next episode, we're going to actually do a little bit of math together and try to understand what Einstein's postulates mean, that the laws of physics need to be the same for all observers, and that the speed of light, being one of the laws of physics, has to be constant, completely defying the understanding of Galileo and Newton and their conceptions of relativity. And again, I hope you're not put off by a little bit of math. We will walk through it step by step, and I could almost say I promise you, but let me say instead, I am, inshallah, very strongly hoping that you will find the exercise very, very worth your while, because you will see the world in a way that you have never seen it before. So we will pick it up right from here, inshallah, in the next episode. Assalamu alaikum.